let's actually go ahead and take a closer look, see if we can actually drill in that high brittle area and get a similar kind of production like we did, okay, in the first, at the start of my presentation. So you're looking at a well of choice which we picked in that high brittle zone. Let's take a look at that in the 3D view. So what you're looking at is again the top and base of our reservoir, right? And those are the two what we call the frameworks. What do I mean by that? For example, if you take the peak where it actually first makes that intersection with the reservoir, if that doesn't line up with the log signature, you just click on the peak and update it. It automatically updates the surface all around it, the up dips and down dips. And not only that, all the adjoining surfaces below that, they get updated as well. So that is the flexibility we have. This is why we call it dynamic frameworks. The framework updates on the fly so that it gives you a better picture ahead of the bit where your reservoir is. So if you notice it in the section view, what you're looking at in yellow is our plan, and in pink is basically the 3D survey. This is the information that can be brought in real time because this tool actually incorporates real-time data directly as well. So we successfully built the curve and geosteered it. Halfway through the well, what we noticed it has actually had sudden drops in rate of penetration, and our mud logger has really reported limestones on the shale shakers, which actually signifies we are going to the Buddha zone. At that point, we asked our geophysicists to step in, take a closer look and see if there's anything that we might have missed. There you go. It actually has a fault right there where we had issues with. Okay? And the greatest benefit that you have is as soon as you incorporate that fault within this live updatable model, it automatically updates on the downstream side the offsets of our surfaces. You can see that from the top in the 3D view as well. It updates our surfaces so that it gives a clear picture where your lateral need to be headed in order to keep in the reservoir. So at that point, we asked our drillers to steer up their mud motors and get it back to the lower part of the Eagle Ford zone on the downstream side of the fault. Again, this information is can be taken instantly into our drilling suite as well because there's tools available not to send that trajectory information, the drill ahead or look ahead trajectory information directly into drilling suite that we have. Now that we have successfully steered the well, the next one is most important part basically. This is where most of our money for this particular well goes to, and this is the most productive part as well. So what you're looking at here is three different views, the cube view, map view, and at the bottom is the section view. Section view, this is a key thing where you can understand those micro fractures that exist within the system. Remember, those are the ones dictate the well positioning. And also you can bring in maps like the brittleness and understand what are my zones, how many stages I can have along the well, which are the brittle zones. You can do your zonal isolation here. And you can also visualize the same microseismic treatment in the 3D view as well. Let's actually take a closer look. For example, if you have the treatment going outside the zone, you can tell the guys, we need to just stop it because we are going out of the zone. It's not going to help out with any reservoir drainage. In fact, it will cause more harm if there's a water table right above that. So you get a clear picture where our microseismic events are in relation to your reservoir. And also if you're coming close to a fault, you can avoid that and not risk losing your entire well. So if you take a closer look, zoom in a little bit, you can actually see that yellow is our plan, and the red is basically our geostate. So if we had drilled it according to our plan, without frameworks updatability, you would lose half of your well. You have to spend that extra money and effort in drilling a sidetrack. There are tools available within this stimulation module where you can calculate theoretically how much of your reservoir is stimulated. You can see it, how it actually updated the surfaces right across that well and gave us a better view. Now that's what we call the stimulated rock volume. Now you can take a look of the same data in the map view as well. So what you're looking at is those different stages. And again, this is what we started out with. We took the existing well frac information. Now we can combine this loop. We take the information, remember the frac direction is always in those in the natural fracs, right? The stimulation direction. Now the well is actually, the orientation of well is dictated by the natural fracs. Now we can take that information, average frac length, incorporate the fault as a subsurface hazard, and develop this entire fill. So what you're looking at here is we took all those stages, we made that as a uniform ellipses of stimulation, and we applied on the entire field. Let's zoom out a little bit. You'll see that it actually applied for the entire field and made that spacing and it also had nice zipper frac between the adjacent treatments so that you are actually stimulating most of the rock. Now this is going to give you a more accurate picture of what would be my total reservoir drainage. So that would be the total drainage you can get, and of course the bottom line for this particular field, and that number will get updated on the fly.